have two special right triangles that you have to commit to memory.
Love you, God.
Now, the easiest way to remember your 30, 60, 90 is this. 30 is the smallest angle, it gets 1. 90 is the largest, it gets 2. 1 and 2 make 3. This can't possibly be the biggest side. This gets the radical. 45, 45, the sides are equal. So make them the same, make them 1. 1 and 1 is 2. One of these has to have a radical. It can't be radical 1 because that's 1. Radical 2. Okay, your unit circle. So it goes out 1 position, up 1 position, over 1 position, 1 unit, down 1 unit. Now, the way we do this on your unit circle is, this is the x, this is the y, in alphabetical order. So therefore, CS, this is the cosine, this is the sine. Tangent is y over x. Oops, that's not showing. Y over x. I'll show you my version of Sokotoa. I'm always mispronouncing, so you have to kind of deal with me. Sokotoa. Thank you. Okay, I'm going to squeeze it in here for a second. Watch. We're going to eventually turn this into y's and x's. And this is how we do it. Easiest way. I found this myself. I developed this little thing myself. Sine, cosine, tangent. On a unit circle. On a unit circle, your radius is 1, right? Then your x and your y. Now watch. Your radius is the same as your hypotenuse, r. A and O in alphabetical order, x and y in alphabetical order. All your a's become x's. All your o's become y's. So the sine is y over r. The cosine, x over r. The tangent, y over x. How easy was that? Sokotoa. C, S, and T. Bring it down. The H is the R. Yeah, look. Put it in alphabetical order. Well, when we get on these triangles, I want you to get used to doing X and Y. And the tangent actually works better if you do Y over X. Okay? Now, let's hit this chart. Okay, let's hit this chart for a second. So, here I am at the 60 degree. I'll convert it to radians in a second. At the 30. Here's my reference angle. Opposite my 90 is my hypotenuse. Opposite my 30 is the opposite adjacent. So, sine, opposite over hypotenuse, 1/2. Cosine, adjacent over hypotenuse, radical 3 over 2. Tangent, opposite over adjacent. And you rationalize, right? So you rationalize, multiply top and bottom by radical 3 over 3, and you get radical 3 over 3. Cosecant. Cosecant, we said, is the reciprocal of sine. Sine is 1 over 2. This becomes 2 over 1, or 2. Okay? Secant is the reciprocal of cosine. Cosine is 2 over radical 3. So it becomes 2 over radical 3. And you rationalize. Radical 3 times radical 3. And you get that one. Cotangent is the reciprocal of tangent. Well, my tangent was 1 over radical 3. Just flip that over before you rationalize. Now, I made you rationalize these because that's what we did in trig. When we get to work with these a little bit more, you actually don't have to rationalize these anymore. But I wanted it to be familiar to you that you were pulling this information from last year, so we rationalize. Now, what I also want you to see is this. When I get to the 60, the 60 is a complementary angle of 30, right? Because 30 and 60 add up to 90. Their co-functions are the same. So the sine of my 30 will be the cosine of my 60. The cosine cosine of my 30 will be the sine of my 60. They're co-functions. Co-functions, they add up to 90. They're complementary angles. In a right triangle, all the degrees add up to 180. You have a right angle, so that's 90 of it. So the other two angles add up to 90. So complementary angles, their co-functions are the same here. Now, my tangent should be the same as my cotangent. My cotangent should be the same as my tangent. My secant is the same as my cosecant. And those, do you see them? Their co-functions are the same. They're complementary angles. You can figure that out without realizing it. You don't have to memorize that part of it. But let me get a good feel for this. My thing on trig is this. If you understand your basic angles, you could do anything in trig. If you don't understand those two basic angles, you're at loss forever in trig. So yeah, it's a little tough giving this to you the night before, but I wanted you to dig down and to see what you remembered and to bring up those special right triangles. Because without this, now, how many of you actually were given a chart or had to figure out this chart last year? Right? Some teachers, I think like Mr. Baker, makes you memorize this. You don't have to memorize anything. One of the teachers, maybe his honors kids, he made them memorize the chart. You don't have to memorize anything. You can automatically find them yourselves off of your two special triangles. Now the 45-45 has its own thing going on. The 45-45, because the sides are the same, the tangent is 1, opposite over adjacent, 1. Therefore the cotangent is 1 over 1. Your sine and your cosine will be the same, 1 over radical 2. If we rationalize it, radical 2 over 2. So you see it? That's a special triangle because the sides are the same on that one. So your sine of 45 is the same as your cosine of 45. They are co-functions. And they're the same angle. When we get to here, this is easiest if you work off of your unit circle. And your calculator does these without a problem. This part, your calculator can do whichever ones are rational. They cannot do the irrational ones. It won't go back to a radical. It goes back to a fraction, but it doesn't go back to a radical. So what we're going to do is make sure we know how to do our right triangles. Now, for these guys, you work off of this. Your sine is your y value. Okay, so the sine at 90, where am I? 90? Okay, the sine at 90 is 1. The cosine is your x value. Remember, x before y, c before x, before s. So your x is your cosine, your y is your sine. When I get to tangent, tangent is y over x. 1 divided by 0. I can't divide 1 divided by 0. It's undefined. If you put the tangent of 90 in your calculator, it gives you an error, out of domain, or cannot divide by 0, whatever the thing happens to say. It cannot do divide by 0. So when we take this one and we flip this over, we get 1. When we take this one and we flip this over, that's not going to work. So this secant will be undefined. This cosecant will be fine, but the secant will not. So are you kind of seeing this? Did I mess up the secant? Where is it? The cosecant? 1. I think this should be a 1.
Yeah.
I think that's 1. I probably messed up a couple of them in here. I was cutting and pasting all over yesterday.
Yeah.
That one's a 1.
For the secant with my accent.
And this one should also probably be a 1 here. Negative 1. Yeah.
Oh, it's 4?
Yes.
Did you
Sign.
grade the thing? That one's 1.
No, I apologize. I did not. Nope, you weren't wrong.
So she does it, okay.
I usually do it as soon as I get the quiz back. Get the test back, but I apologize, guys. I did not. Okay, so check my table. My table was a little off. I ran all the numbers down in one and I probably just didn't replace it.
So that's all?
That's it.
Oh, so you told.
I'm sorry? Oh, no, that's not all we're learning today. No. Okay.
What's that question? The one question I asked, one that's something like that.
No, it's not the same question.
No,
The questions that are not
that's
asked.
what I'm trying to say.
Yes.
So,
Yeah. Okay. So, is everybody okay with this? You can find these. Yes? Okay, you've got to know your special right triangles. That has to be. So, let's go to today's work. Today, we're hitting your unit circle. So, we're going to talk your unit circle. We're going to talk about your functions. You have this on your paper? Do you have the functions? Okay. We're going to talk about your functions and your reciprocals. Now, this is why I said that we need to go to x's and y's. Because the easiest way to do this is we locate on our unit circle where our triangle resides. We find our x, y, our y, and our r, and we can find any trig function that we need to find. Now, what's unique about your unit circle is your radius is 1. All the time. Now, here's an issue. We'll get to your issue in a second. Here's your points as they spread out again. And this is your x and your y, your cosine and your sine. So, on the unit circle, your x is automatically your cosine. Your y is automatically your sine. Even if I have on my unit circle a 30-degree angle. Now, here's a problem. This now has to be 1. But I memorized this as a 2. I memorized my hypotenuse as a 2. But I now need to make it a 1. I need to make this a similar triangle. So what do you think, Chris? What should I do to get to 1? See you calculating. No? You weren't? How do I get from a 2 to a 1? Divide by 2. Oh, so if I divide this by 2, I divide this by 2, I divide this by 2. And that's called the similar triangle. So, opposite the 30 is my 1/2. Opposite the 60 is my radical 3 over 2. Now, this is how they usually write it. The x value, comma, the y value. So therefore, x, y, cosine, sine. Isn't the cosine of 30 degrees radical 3 over 2 on your chart? Isn't the sine of 30 degrees 1/2? On the unit circle, it has unique little features. Because the radius is 1, if we put it over 1, it is itself. We just have to make the radius be 1. So once our radius is 1, then our x is the cosine, our y is the sine. Our tangent, therefore, is y over x. So our tangent would say, take the 1 over this guy. We're not going to panic, because we know the rule. We keep this, we change, we flip this over, and this is one big line. Out comes the 2's. So what is my tangent? 1 over radical 3, which isn't it radical 3 over 3? Just like your chart? These are similar triangles. That's all this means. No matter what radius I give you, you create a similar triangle. Your sine of 30 is always going to be 1/2, regardless of what your radius is. If I put this on a circle whose radius was 4, and I said this is a 30-degree angle, and I say, oh, I thought this was a 2. Now it has to be a 4. So I have to multiply everything by 2. I multiply my 1 by 2, I get 2. I multiply my radical 3 by 2, I get this. I can still find my triangle. it's a similar triangle. Your sides are in proportion. So all you have to do is work with one measurement. Did I multiply by 2? Did I divide by 2? Did I multiply by 3? Did I divide by 3? Just figure it out that way. Now, these stay the same. The sign is always going to be the y over the r. On your unit circle, the r happens to be 1. That's why the sign is the y. On your unit circle, your cosine is always x over r. On your unit circle, it's a 1. Therefore, my cosine is an x. Okay? Your unit circle is kind of like anything. It has one radius, the same all the way around. It makes it a little bit easier for us to chart through. And once we find these things, we're okay with this. Now, your reciprocal functions work like this. This is the easiest way to remember this. Here's your cotangent, here's your cotangent. They start with different letters. So your sine can't start with an S. It has to start with a C. Your cosine can't start with a C. It starts with an S. So you've got a sine and a cosecant, reciprocals. A cosine and a secant, reciprocals. Your reciprocals start with different letters. I know it sounds better to say sine, secant, but they can't start with the same letter. Sine, cosecant. Cosine, secant. And all you have to do for those are find the original one and just take its reciprocal before you rationalize. So you really don't have to memorize these functions. Just go back to the original and take its reciprocal. Okay? All right, so let's see what else we got here. And here's your triangles in standard position. Now, standard position is this. Here's the way your graph works. You start right here. All your angles open in standard position. They open from your positive x-axis and they go counterclockwise. This is how your angles rotate. Counterclockwise from your positive x-axis. This is called a terminal side. Your angle technically goes from here to here. And it stops at the terminal side. What we drop, and we'll talk about this the next day we have class, is a reference angle. That's down here. That reference angle will help us find your angle. But the angles will all start in standard position, and they will terminate wherever we stop it from going any further. Now, if we're on a unit circle, we can assume that your radius is 1. If we're not on a unit circle, we'll use these guys. Whatever radius you come across, you just take your hypotenuse and work with that and make it happen. Whether you have to multiply it by 2, divide by 2, whatever you have to do. So, let's locate where these are. When you go from, and then I noticed a couple of you were missing this part. When you go from radians to degrees, and degrees to radians, you have to remember one thing. Pi is 180 degrees. That's the one thing you have to remember. So say I start with 30 degrees, and I want pi, I multiply with pi on top. And I just reduce this piece. 30 goes into 60, 30 goes into 180, 6 times. If you want the pi goes on top. If you have the pi goes on the bottom, and 180 goes on the top. So you can cancel those out, and then just do a regular divide. So when you're going from one measurement to another, you just have to remember that 180 degrees is pi. 360 is 2 pi, right? Make sense? All right, so we're looking for an angle that's how many degrees? 30. And so what quadrant is 30 degrees located in? The first one. So we drop a triangle. Now, if you want, you can use your unit circle. Make this easy. Let's use our unit circle. This is a 1. So we said, okay, here's my 30. This is 1, 2, radical 3. So to go from 2 to 1, we had to do what? Divide by 2. So we divided everybody by 2. So opposite my 30 is 1/2. Opposite my 60, that's inside my circle and just came out, is radical 3 over 2. The radius of a unit circle? Yeah. Yeah.
Yeah, of course.
Well, yeah, because I want you to see it going around the circle. Now, this is how we do this. This is Moore's way. We make an information box like this. We're in quadrant 1. So x and y are positive, right? So my x value, 1/2. My y value, sorry, reverse this. My x value, radical 3 over 2. My y value, 1/2. My radius, 1. Your radius is always positive, no matter what quadrant you're in. This is your information box. From here, we can find any one of your functions. We're on a unit circle because your radius is 1. So my cosine is x over the r. My cosine is automatically my x value. My sine, y over the r, automatically my y value. My tangent, y over x. Reciprocals, you can take these guys, take the reciprocals of them, right? To find your 6 functions. Now, if I took this, watch what happens, and I move this into quadrant 2. I'm going to reflect this triangle over the y-axis. Doesn't the triangle stay exactly the same? Shouldn't this be 1/2? Shouldn't this be radical 3 over 2? Shouldn't this be 1 if I reflected it from here? I just took the triangle and reflected it. Right? There was my 30, my 60. Right? I just reflected this. Now watch. X, Y, R. What's X? In quadrant 2, is X positive or negative? Negative. Is Y positive or negative? Positive. My radius, always positive. So here's my information box. From here, I can find all of my functions. I say the cosine of this angle is my x. Negative radical 3 over 2. It's in my information box already. I don't have to worry about all students take calculus or whatever what you say. Sine is my y, 1/2. Tangent is my y over x. I take my y, I put it over my negative x. Remember, we flipped this around. So your tangent is negative 1 over radical 3.
So is that the answer, or you just want to
Yes. No, this is it. I just moved this now into quadrant 2. Just to show you that you can find the same exact attributes no matter what quadrant you land in, just by doing this.
Can you do the original one?
No. I just wanted you to see, no matter what quadrant I reflect this in, doesn't this all stay the same, but the only thing that changes is if it's positive or negative? Okay? Doesn't matter what quadrant I put this in. That's all going to stay the same. It just depends where it lands. Okay, let's go to this one. Let's go to the next one. This guy. What degrees is this? Three goes into 180 how many times? So it's negative 60. Well, if my positive angles start here and open counterclockwise, where do my negative angles go? Clockwise. I start here, I go clockwise. I make a triangle down here. What angle is this, did you tell me? 60. So, I'm on a unit circle. I label my sides. Opposite the 30 was my 1/2. Opposite the 60 is my radical 3 over 2. Right? Same triangle that we just did. It's just a different perspective because 60 is my reference angle. But watch. What's x equal to? 1/2. What's y equal to? Negative radical 3 over 2. This is your y. What's r equal to? 1. So now, I say, okay, give me the sine of t, of this guy. Give me the sine of t. Sine, I go here, up, I got it. Give me the cosine of t. Up, I go to my x, I got it. Give me the tangent. Right from here. On your unit circle, remember the x is the cosine, the y is the sine. Because if I put it over 1, it's itself, right? Isn't the cosine x over r? But r is 1. So isn't the cosine on my unit circle the x value? Yeah? So what's tan? Tan is y over x. Take my y over my x. Don't panic. We just keep flip it over. What happens to the 2's? Cancel out. So what's my tangent of this guy? Negative radical 3. Now from here,
So a sine y over r.
y over r. But what is r right now? 1. So on the unit circle, sine is the same as just y. If the unit circle is not there, if the radius was 2, we'd put it over 2. But the radius is 1, so anything over 1 is itself. Now, my reciprocals. This guy gets the c. Here's my cosecant. Flip this over. Negative 2 over radical 3. My cosine is my secant. Flip this over. Oh, 2 over 1. Cotangent. Flip this over. Oh, negative 1 over radical 3. You just found all 6 trig functions. Now from here on in, you don't have to rationalize them. You can leave them like that. You don't have to rationalize. I had you rationalize because that's what you did in Algebra 2. So once we locate your triangle and we pull out your x, y, r, we can find all 6 of your functions like that. When you're on a unit circle, your radius is 1. So even though we say x over r, x over 1 is still whatever x is. Okay? Let's try another one. What degrees is this? 45? Okay? I'm in quadrant 1. 45. Now, I remembered my triangle as 45, 45, 1, 1, radical 2. But on my unit circle, my radius has to be 1. How do I get this radius to be 1? No, how do I get radical 2? What do I have to divide radical 2 by to get me 1? Radical 2, divided by itself, right? Oh, so divide this by radical 2. Divide this by radical 2. So these sides are both 1 over radical 2. We want to put it on the unit circle. If I didn't say unit circle, you can just do this one and do x, y, and r. But today we're just doing unit circle. Now, what's x? What's the value of x? What's the value of y? What's the value of r? So, the cosine of my angle is my x value. The sine of my angle is my y value. My tangent is y over x. What if I put 1 over radical 2 over 1 over radical 2? What is anything over itself? 1. You got all your negatives and positives laid out right here. In quadrant 1, everybody's positive. Okay? If I did this, and I moved this, I'll show you a real neat way next time. This isn't down here in this quadrant. But watch, this has the same thing. 1 over radical 2, 1 over radical 2. X is now negative. Y is now negative. And R is positive. It's the same thing, just reflected into quadrant 3. Okay, so tonight you're going to work with your unit circle. The X is here, because this would be the point here, XY. The X is along the X-axis. The Y, Alex, is parallel to this Y.